Hi, my name is Kent Lee and I teach computer science at Luther College. One of the things that we have to do when we write computer programs is read data files. That is frequently done, and thankfully there has been some standardization of the format of data files over the last 15 to 20 years. And one of those standards that has really risen out of the pack is called XML. XML is a very common format for writing data files, for creating data files, and because of that, I think it's worthwhile for you to learn something about the format of an XML file, what an XML file is, and also how to read an XML file. So I want to give you an example. I went out on the internet, on Google, and I searched for a XML file that would give me some information about populations of cities in the United States. And I found this XML file. This was available at the World Gazetteer website, a mapping website, and I was able to download this file from that includes populations of cities in the United States, along with their longitude and latitude coordinates for a map. So I got this information, and this is an XML file that we are looking at here. I know it's an XML file because it starts out with XML in a tag at the beginning of this file. Every XML file starts out with a less than, a question, and then XML as the next three characters. This happens to be an XML file that's in version 1 format, and it has a UTF-8 encoding, which we don't really need to worry about. It just means that it's coded with characters that we can read. So the next tag, these are tags that are within the XML file, and the next tag is a KML tag that appears in the file. And that KML tag starts here, and if I were going to look at the whole thing, it starts here and goes to here. So that is the KML tag. And every tag, pretty much every tag in XML has a beginning and an ending to it. So this is the beginning of the KML tag. And actually, if I scroll down in this file, I have to go down quite a ways, but if I scroll all the way to the bottom, there is the end of the KML tag, and I can tell that because it's a /KML that's inside of a less than, greater than. So XML tags almost always have a beginning and an end to them. The beginning is labeled with some name, and the end of it is labeled with a slash and that same name. So we have a KML tag that extends throughout this entire document. If I go back to the beginning here and look at it again, right after the KML tag, so the KML tag starts here, the beginning KML tag starts here and ends right here, and right after that I have a document tag. So there's the beginning of the document tag, and again, if I want to find the end of it, it turns out that the document tag ends way down here at the end right there. So there's the beginning and the ending of the document tag. Now these tags are nested within each other. The KML tag is on the outside and the document tag is within the KML tag. It's in between its beginning and end. Here is a name tag here that's within the document tag. So that name tag starts there and ends right there because that's where the /name is. So we have the beginning tag and the ending tag, and we have some data between those tags, some information. This is how data is encoded in an XML file. We put a tag around the data, and then we can put the data in the file. This way, the data that we have, in this case a title that we have for this information, is given a name. In this case, the name is name, in this case, the name tag. There are some style tags then that still appear within the document tag, and I'm not really interested in those style tags. I'm going to skip past those and go down to the first placemark tag that we're looking at in the file here. And here's our first placemark tag right here. So placemark starts with placemark and ends with /placemark right here. So there's the beginning and the ending of the tag. And then within that we have some information. So we have a city name. There's a name given to our city, some description information that is useful for, this is for Google Earth. We don't need to be we don't need to worry too much about that information, except that population right here is of some interest to us. So we're going to actually dig into there to get the population data from that description tag there eventually. And it turns out that the longitude and latitude are also within that file, and they're right there, longitude and latitude, and then the third coordinate, which we aren't really interested in there. We just want longitude and latitude. So there's some information we would like to extract from this file, and I'm going to show you now how to go about extracting that information from the file. So we'll come back to this in just a moment here. To get started, I'm going to have to import some code from a library, and in this case the library that I'm going to import is from a library called XML.dom. So I'm going to say from XML.dom import minidom. So minidom is a library that I can use from this XML.dom module, and I'm going to go ahead and use that in my program here. And the minidom library lets me do something called parse, parsing an XML file. Now, parsing is a word that is used in computer science to say that we're going to use some kind of a grammar to read some information from a file, and we're going to split that information up into its logical pieces by parsing it. So all that means, if you think in grade school of the sentences that you had to identify the parts of a sentence with a grammar, we're going to do the same kind of thing with an XML file. We're going to identify the parts of an XML file by parsing it. Thankfully, we don't have to do that ourselves. That code has already been written for us, and it's very easy to do. So what I'm going to do is I'm going to write a line here, xml.doc equals minidom.parse, and I'm going to say the file that I want to read. In this case, that file was called KML.kml. And so we have, after we have executed that line, when it runs, we have parsed the XML file, the KML.kml XML file. It's like I forgot a quote there. And there's nothing more to reading that file. We have read the entire file by writing that one line of code. This is one of the advantages of XML, is that we can read a whole XML file by writing just a few lines of very simple code. Now we have to understand a little bit about this library and how we get at the information that we have just read. And to do that, we're going to go back here and we're going to look at what we've got for our format of our file. Then I said the first tag after the XML tag was this KML tag. Well, we can get, in fact, that KML tag starts there and extends for the entire document. We can get a piece of information from an XML file by calling a method on the XML document. And in this case, I want to get the KML tag, and that's going to be equal to, so I'm using a variable name called KML, but I want to get it from XML.doc, that's from my document, and the method that I want to call is getElements by tag name. And the tag that I'm looking for is the KML tag. That essentially gets the entire document again from this XML doc, except that now I have just the KML tag. And actually that returns getElements by tag name returns a list of all tags that match the KML tag name in the file. There might be more than one KML tag, it's possible, one after another. In this case, I happen to know that there is one, but I have a list of them. So if I want just the first thing in the list, I'll do Subzero to get the first element of that list. Remember, getElements by tag name always returns a list. So Subzero will give me the first one. Now within the KML tag, we saw that there was a document tag. So I'm going to say document equals, and from the KML tag, I'm going to call getElements by tag name again. And I'm going to ask for the document tag. Notice I had to spell it exactly as it appears in the file. And once again, there is exactly one element of the document tag within the KML tag. So I'm going to do Subzero here to get the document tag. Okay, now let's go back and look at this one more time here. We've got this KML.KML, we've got the document, okay, and the document extends all the way to the end. We had name begins and ends there, so name we don't have to worry about going into the name tag here. And then we have a style tag that comes after the name tag, and we don't care about those style tags, as I said. But we do care about these placemark tags. So these placemark tags start right after the style tags, and I want to get all the placemark tags. So I'm going to get them, I'm going to call that list that I'm going to get placemarks. So we're going to do that next. Placemarks equals, and it's from the document, and it's get elements by tag name again, and I'm getting placemark tags. So we're asking for the placemark tags. I wouldn't write placemarks in this case because I want the placemark tags. So I have to put placemark there as the string that I'm looking for, the tag name that I'm looking for. But I know I get a list of them, and it's a list of placemarks. And I'm just going to do a real simple for loop here to go through that placemarks list. I'm going to say for placemark in placemarks, and I'm just going to go ahead and print placemark at this point so we can see what is it that we're getting here and just see if our code is working up to this point. So I'm going to go ahead and run this. I'm asked to save it. I'm going to save it in this directory, and I'm going to call it extract because I'm trying to extract some information, extract population data, and we'll just save it. And sure enough, I get a whole bunch of placemark objects. These placemark objects are DOM elements. DOM stands for Document Object Model, and that really just has to do with it being an XML file. So these are DOM element objects, Document Object Model element objects, and each of them is a placemark. I can see the reference there that goes along with each of these. This is the reference that points at them. So placemark is a reference to the placemark objects that we have there now. Okay, well, it's not very interesting to print the placemark stuff, so I'm just going to get rid of that now that I've seen that I am going through my list of placemarks. And within a placemark, I have some more information that I want to get. Let's see here. The first thing I'd like is the population. Population comes from the description tag that's within the placemark tag there. So I'm going to get, let's see, name begins and ends there. Description is just a tag inside a placemark. I'm going to get that information, and if I look through this data here, I am going to find that the first thing I find is a colon, and the colon comes right before the population there. So I am going to take and first of all get the description tag. I'll just call it DESC equals, and I'm going to go into the placemark tag and do get elements by tag name again. And I'm going to get the description tag from that, and I think it was spelled with a capital, with a small d. So I need to use a small d here as well. Description. And I get a list of description tags. I know there's only one that I want, so I'm going to do Subzero on it to get that description tag, just the first one. And in this case, I want all of the data that is between the description tag. And to do that, I am going to do a dot first child dot data. So dot first child dot data should give me the description information. Let's just go ahead and print that and see what that looks like. So we'll go ahead and run this. And there you can see I've actually got all of the description information there. Now, population is right after the first colon, so I'm going to go ahead and split that. We'll take the print back out at this point, and we'll go ahead and split that, and that's just going to give me a list. List is equal to DESC dot split, and I'm going to split on a colon in this case. Okay, and that means that I am getting close now to the population value I want. List sub, let's see here, everything before the colon is going to be list sub 0. After the colon is list sub 1. So I'm going to do list sub 1 for the beginning part of the data, and I'm going to actually split it again. So I'm going to get list 2 equals list sub 1 dot split, and I'm going to split it on a less than symbol that comes right after the population data. So if I do that, then sub 0 of that will be the population. And actually, you know what? I don't even need list 2 if I do all of this in one line. The population of this is a float, or actually an int, isn't it? Can't have a part of a person. An int of that information there. So again, I went into list sub 1. List sub 1 was the beginning, was basically starting here and going to there because I split on colons. I want to get rid of the rest of this, so I split again on a less than. That splits right on that thing, so this would be in that new list at position 0, and then I did an int on that to get the population out of it. Now, I still want to get the longitude and latitude from this. The longitude here is in coordinates, along with both the longitude and the latitude are in the coordinates field down there. So we're going to go ahead and get the coordinates information. Coords equals, and this is in the place mark again, dot get elements by tag name, and it's called coordinates, I believe. Let's take a look again to make sure. Let's see here, coordinates, and we'll do a right parent, and that's a list of them. We know there's only one of those things in the list, so I'm going to do sub 0, and then I'm going to do first child dot data to get the information between the beginning and the ending tag there. So chords is a string at this point, and then I can go ahead and split that string. We'll just call it list 2 equals chords dot split, and we're splitting on a comma in this case because those coordinates are separated by commas within the coordinates tag there. So we separate by comma. Then we know that the longitude, it is the longitude first, and then the latitude second, and then some information I don't care about third. So list 2 sub 0 is the longitude. Longitude is equal to list, and we're going to do a float of list 2 sub 0. Latitude is equal to a float of list 2 sub 1, and again we don't care about the third piece of information. So I am going to now print this information to the screen just so we can see. Oh, and we wanted city name as well. We ought to have the city name. The city name is in the name tag right after the place mark. We can go ahead and get that as well. That's just going to be city name, and that's going to be equal to place mark dot get elements by tag name, and we're specifying the name tag. We get a list of those, so we've got sub 0. We want just the data that's in between that, so it's first child dot data. That should be the city name that we want. So now I'm going to go ahead and print that information to the screen. I'm going to print city name, followed by a colon. I'm going to add a colon to it, and then I'm going to provide the other information. We're going to do the longitude, the latitude, and the population, and print all of that to the screen. So let's give it a run and see what we get as our output. And there we go, we've got our information. Longitude is all negative numbers, it turns out, for the United States here. I'm just going to go ahead and print the opposite of the longitude here just to make those all positive numbers. We should know that longitude runs from east to west in increasing order once we have negated all of them. So there's the information from the XML file. An XML file, again, has tags in it. There's a beginning and an ending to each tag. The beginning tag starts with the name, and the end of that tag starts with the same name with a slash at the beginning, so you can tell which one's the beginning and which one's the end. Each tag may have other tags within it, and there is data that appears in between the beginning and ending tag pair names. So that, in this case, name is the name of the city, and that's the data that we use to get it. The advantage of using XML is that new tags could be added to this file later. We don't have to stick with just this format forever. We could add more information if we wanted to. That extra information would not affect our program at all. We would not have to rewrite anything in here as long as the tags that we were looking for remain there with the same format. But additional tags could be added, and that is the real advantage of XML, is that you can add additional information later on as long as you don't change the format of the existing tags. Programs that use that data do not have to change. That's it for this time.